All right, welcome to the last part of section 6.4. So what we're going to do here is we're going to graph something that looks like this. We've already done something similar to these two problems when we graphed circles, but the thing this time is that it might be any type of graph. It could be an ellipse, it could be a circle, it could be a hyperbola, a point, or even no graph. So we're going to use the completing the square process to do this again. So let's get started. So they've already lined this up for us with x being together and y being together and the number over here. If this hasn't been done, you need to rearrange it to get it to look to be in this form. Then we're going to complete the square twice, once for this and once for this. Now, remember that the completing the square process only really works if this is x squared by itself. So watch what I'm going to do. I'm going to do something a little tricky here. I'm going to factor out a 16 out of only the first two terms. Okay, this is going to be a little tricky. So I get 16 factored out of x squared minus 16 times 4 is 64. So I factor it out like that. So you notice if I do the distributive property, I get 16x squared minus 64x. Okay? I'm going to factor the 4 off of these two terms because, again, I need y squared by itself. So this is going to be plus 4 y squared minus 6y. And I've made a mistake here. This should be 4x. This should be 4x right here. So x squared minus 4x, y squared minus 6y, and this still equals negative 36. So that's all I've done so far. I just factored off the 16 and I factored off the 4. I only factored the 16 off these two, and I only factored the 4 off of these two. Okay, now we're going to do something real tricky, which is I'm going to do the completing the square thing. And remember how we do that. We take the b term, which is negative 4, divide that by 2, and square it. So it's negative 4 divided by 2, which is negative 2, and then you square that, which gives you 4. So there's the magic number for this one. Let's do that same thing for negative 6. It's negative 6 divided by 2 quantity squared, which becomes negative 3 quantity squared, which becomes 9. So the magic number for this part is 4, and for this part is 9. So let's add that in. 16 times x squared minus 4x plus 4 plus 4 times y squared minus 6y plus 9 equals negative 36. Now here's kind of the tricky part, so make sure you follow this really closely. I added 4 and 9 to the left side of the equation. Do you agree with me? So I need to balance the equation. But it's not enough to just add 4 and 9 over to this side. And the reason it's not enough is because I didn't really add 4. I added 4 times 16. Because if I did the distributive property, I'd actually get 4 times 16. So even though it looks like I only added 4, I actually added 64, which is 16 times 4. So I need to add 64 to the right-hand side to balance off that 4. Same here. I didn't just add 9 here. If I just added 9 to the end, that would be okay. I added 9. But I added 9 inside of a parenthesis that's timesing by 4. So in fact, by adding this 9, I actually added 36. So I need to add 36 to the right side. And now the equation is balanced. So I know that's kind of tricky, but hopefully that makes sense. If it doesn't make sense, watch that last few minutes again. Now remember, the middle part of finding the magic number tells us how this factors. So this is 16 times x minus 2 quantity squared plus 4 times y minus 3 quantity squared. Okay, or you can just know how to factor this. That works as well. And then over here, negative 36 cancels with 36, and I get 64. Okie dokie. So it doesn't look like to me that this is going to be a circle, because I have numbers with my x squareds. So let's make the right-hand side equal 1. Let's divide everything by 64. Because that means the right-hand side is going to equal 1. 4 and 16 cancel, so I get y minus 3 quantity squared divided by 64 divided by 4, which equals 16. And here 16 and 64 cancel, so that's going to be x minus 2 squared over 4. Aha! After all of that work, we now have it in a form that we will be able to graph. And hopefully you recognize that now that we've got the equals 1, we have a plus here, so that's the equation of an ellipse. So let's graph the center, flip the signs. The center is going to be 2, 3, which is right there. That's the center of my ellipse. It looks like the major axis is with y, because that's the bigger number. So take the square root, so it's going to be up and down 4. And left and right 2 is the minor axis. And then you just draw on your ellipse, and it kind of looks like an eyeball. Whoop, there you go. So you couldn't really tell really what it was going to be just by looking at this until we kind of did some math to it and got it in a graphable form. Luckily, the process is going to be exactly the same for this next example. We have x squared plus 12x minus y squared plus 2y minus 6 equals 0. So the first thing I need to do is my x's are together, the y's are together. So let's add this 6 over. So we add the 6 over, plus 6 plus 6. That cancels. So I get x squared plus 12x minus y squared plus 2y equals 6. Okie dokie, so what do we do now? So let's go ahead and do our completing the square. So my first number is 12 over 2 quantity squared, right, because of the 12. So that becomes 6 squared, which becomes 36. And here I've got, now we've got to be a little careful here because of this minus right here. And so we got to think about this a little bit. What I'm going to do is I'm going to do something tricky. And again, remember how we factored out the numbers in the previous example? We factored out the 16 and we factored out the 4. I have to do something similar here because I can't complete the square unless there's a positive 1 in front of y. So what I'm going to do is I'm going to factor out that negative, which turns this to positive, and it flips the sign of this. So do you see how I have y squared and negative 2y? Now there's a 1 here, so I can complete the square. So that's going to be negative 2 divided by 2 quantity squared, which is negative 1 quantity squared, which is 1. So my magic numbers are 36 and 1. So watch how I add these in, and then I think this will make sense. For the x, because the x is nice, because it has a 1 in front, it's just x squared plus 12x plus 36. There's no weird parentheses, and so I'm just going to add 36 to the right-hand side. But with the y, it's inside the negative. So it's y squared minus 2y plus 1. And I had to add it inside the parentheses, which are being with this negative sign out in front. So I've got the 6. So with the 36, I just added it. So it's plus 36. That's nice. But this 1 I added. But if I applied the distributive property, I actually subtracted it. Do you see that? I actually added a negative 1. Because if I do distributive property over here, a negative 1 just appeared. So I actually have to write minus 1 right there. So I know that's kind of tricky. But if you have a negative sign in front of the y squared, you actually have to factor it off, which flips the signs of the stuff that you factored it from. So negative turned positive, positive turned negative. Now you can complete the square in the parentheses because the y squared is positive. And we figured out that it was 1, so we added 1 in. And because of the negative sign in front, when I added the 1 in here, it was actually like subtracting a 1. Pretend for a second there had been like a negative 3 right here. If I added a 1 in here with a 3, I would have had to subtract 3 because you have to multiply them like we did up above. Anyway, I don't want to do too many more hypotheticals because this is tricky enough to explain as it is. So our first one will be x plus 6 squared because 6 was my middle step. And over here, it's going to be minus y minus 1 squared because minus 1 was my middle step. Then over here, I have 6 plus 36, which is 42, minus 1 is 41, like that. Okie dokie, so can you tell what this is a graph of? This minus sign should be a clue. Looks like the graph of a hyperbola. So let's divide by 41, divide by 41, divide by 41. So that's going to give me 1 on the right is equal to x plus 6 quantity squared over 41 minus y minus 1 quantity squared over 41, which is a hyperbola because of the minus sign. So our center is negative 6, 1. Oops. 1, 2, 3, 4, 5, 6, 1. There's my center point right there. Because again, you just flip the signs. X is coming first and being squared, so that means we're opening up left and right. And it looks like it's just going to be kind of a square box this time instead of a rectangular box. And the length is the square root of 41. So let's do 41 square root and see what that's equal to. It's about 6.4. Okay, so we need to go up 6.4 to there, down 6.4 to there, over 6.4 about there, and over 6.4 to about right there. And again, this is just a sketch. We make our box. And again, it's 6.4 in every direction just because those two numbers are the same. So now draw in your negative and positive asymptotes through the corners of the box. And again, x squared was first. So that means we're opening up left and right. So here's one vertice, here's the other vertice. So it's opening like this. And there's the graph. So there's your hyperbola. So you can see the process to getting to here was pretty much the same as the ellipse. The minus sign makes it a little bit tricky in front of the y squared. So if you have questions about that, please rewatch this or leave me a question in the comments and I'll answer it. That's the end of chapter 6. You know how to graph the conic sections. And the reason they're called the conic sections is because they all come from this diagram right here. If I have two cones like this, kind of like an hourglass that meet at the middle, all of the conic sections are derived from different slices of planes through here. So like for example, if I do a plane like this, I get an ellipse. I actually get a circle if it's completely flat. If I do kind of a diagonal plane like this one, I get an ellipse. And if I do a plane like this that kind of goes through them top to bottom like this, you can see that where they intersect is actually a hyperbola. Oops, I should have come down the other way, but you get the idea. So all of the different, and if I draw a plane right through the middle, it only touches in one place, so that's a point. If I do a plane this way, I get a line. And if I do a plane like this one, I get a parabola. So that's why they're called conic sections, is they're basically, you can find better diagrams than this one on the internet if you just go to Google or Bing and type in, or DuckDuckGo, go into a search engine, type in conic sections, and you'll see a diagram that looks better than this one. But that's why they're called the conic sections, is they all come from different planes going through these cones. So I hope you've enjoyed chapter 6. If you enjoyed this, please like and subscribe. Any questions, leave them in the comments. And I will see you next time. Have a great day. Thanks for watching.